Welcome to C.M.P lab. In today's class, we are going to talk on logarithm. What is logarithm? What are we actually doing when we are solving logarithm? Okay, we have here that the logarithm of a number, say n, to a certain base, say x, is the power to which x must be raised to give n. Okay, so if we write this statement down in a mathematical form, this means log n base x. Okay, and the definition says that the logarithm of a number, say n, to a certain base, say x, logarithm of a number, okay, say n, okay, to a certain base, say x, is the power to which x must be raised to give n. Okay, so the log or a log of a number is the power which x, okay, is the power which this x will be raised to give us n. Are you with me? Okay, so if we write this down in equation form, okay, we in an equation form we'll have x, okay, we don't know the power we can raise our x to, but let's term the power we raise our x to a. Okay, let's raise our x to a power, say a. Okay, all right, so this will be an equation form of this because it said it is a power which x must be raised to obtain n. It's the power which the base, this is the base x, okay, this is n, which is the number. Okay, this is the power which this base will be raised to obtain n. Okay, so this is it in the equation form or exponential form. Okay, because every logarithmic form has an exponential form. Okay, every logarithmic form has an exponential form. So this statement, this is the exponential form of it. Okay, all right, that the power x will be raised to, we say let it be a equal to n. All right, okay, let's give our n and x a number. Okay, let n be equal 16 and x, okay, and our x be 2. All right, so that we can write this in this form. Okay, that log our n is 16, log 16, and our x is 2, log 16 base 2. Remember, logarithm says that the log of a number, the logarithm of a number, say n, to a certain base, say x, is the power to which x must be raised to give n. Okay, is the power which the base will be raised, okay, to give us 16. That is to say, what is the number, okay, that 2, which is the base, will be raised to for us to obtain 16. Whatever power which 2 will be raised to for us to obtain 16 will be the log of this number. Okay, will be the log of 16. Okay, so now we said we write this down in the index form. Okay, we don't know the power 2 can be raised to. Okay, so let's say let the power 2 can be raised to be x, since we don't know. Okay, we say 2 raised to the power of x, 16, okay, equal to 16. This is the exponential form of this logarithm. Okay, so that if we write this, we can have that 2x equal to, writing 16 in its index form, this is 2 raised to the power of 4. Okay, all right, this is 2 raised to the power of 4. Okay, we have 2, the bases on the both sides of the equation are equal, so this will cancel this, and we have that x is equal to 4. Okay, all right, remember I told you that logarithm, every logarithmic form has an exponential form. Okay, so here are some example of logarithmic form and exponential form. Okay, some exponential form of some logarithmic form. Okay, or of some logarithm. Okay, so like log m to base a. Okay, this is the the exponential form. Log 32 to base 2 equal to 5. This is the logarithmic form of this statement. Okay, this is the exponential form, sorry, of this statement. Okay, this is the exponential form. So log 32 to base 2 equal to 5. Okay, is 2 raised to the power of 5 equal to 32. Okay, this statement says that 2 5 sorry 5 is the power which 2 will be raised to for us to obtain 32. All right, so this is the log. Okay, this is the log. 5 here is the log of 32. Okay, so log 32 base 4 equal to 5 all over 2. This is the exponential form. Log x, okay, to base 10. Okay, any number, anytime you don't see a log, okay, anytime there is no base written for a log, you just know that that log is in base 10. Okay, we call it a common log. All right, so log x to base 10, okay, is equal to 5. All right, this is the log x base 10 equal to 5. This is the exponential form of it. Okay, we are going to solve some problems, simple problems on logarithm. Okay, the first question says, okay, no, the question says solve the following. The first question is log x to base 5 equal to 2. Okay, now this statement says that what will be the number, okay, if the base, okay, is raised to the power of 2. If the base of this log is raised to the power of 2, what will be the number of 10? Okay, so we solve this, that a is equal to log x is 5 is equal to 2, that we have here that x equal to 5 raised to the power of 2, okay, and x is equal to 25. Okay, so we go to the next question that says log x is 81 equal to so we first write this in the exponential form. This is 81 raised to the power of which is equal to x. Okay, or we can put it this way. All right, can put it this way, that x is equal to 81 raised to the power of all right, so that x is equal to, remember in your indices, okay, that our half is the same thing as square root of square root. Okay, yes, so this is root 81. Okay, so that root 81 is equal to 9. Okay, so we can check this if this is correct. All right, if this is correct. Okay, right, so we bring out the index form, the exponential form first. Okay, x is equal to, check that x is equal to 81 raised to the power of Okay, now we have here that our x is equal to 9. Okay, our x is equal to 9. Okay, equal to 9, and we know that our half is square root. Okay, so this is can be written as square root 81 raised to the power of half can be written as square root of 81. Okay, our half will turn to square root. Okay, such that square root of 81 is equal to 9. So you can see that what is on the left hand side is equal to what is on the right hand side. Okay, we are going to consider the C question, and the C question says that log x base 9 is equal to minus 1 all over 2. So if we raise this, okay, we have that x is equal to, okay, we raise this is the log, the number to which we raise the base to. Okay, this is the number to which we raise the base. Okay, all right, so the base to, yes, so we have 9 minus 1 all over 2. Okay, so that if we write 9 in its index form, this is 3 raised to the power 3. Okay, minus 1 all over 2. Okay, so that 3 times minus a half will be 3 minus, sorry, this is 3 raised to the power of 2. Okay, this is 3 raised to the power of 2. Okay, so that 2 times minus a half, we have minus 2 all over 2. Okay, minus 2 all over 2. Okay, all right, so that 2 here cancel itself 1 and cancel itself 1, and 1 divided by 1 is 1. So we have x is equal to 3 raised to the power of minus 1. And in our indices, let me put this well, let's take it over here. X is equal to 3 raised to the power of minus 1. And for my indices, we know that 3 raised to the power of minus 1 can be written as, okay, any number raised to the power of minus 1. 3 raised to the power of minus 1 can be written as, okay, 1 all over 3. All right, so x is equal to 1 all over 3. Okay, we'll go to the next question, the D question. It says that log 27 base 3 is equal to n. Okay, this statement means what will be the power, okay, that will raise 3 to for us to obtain 27. So if we write this down in exponential form, okay, we'll have that 3 raised to the power of n is equal to 27. Okay, so that if we write 27 in its index form, this is 3 raised to the power 3. Okay, this is our power n here. Okay, power n. So now you can notice that the base on the both sides of the equation are equal, so they cancel off, and we have that n is raised to the power 3, n raised to the power 3. Okay, let's check this if this is actually correct, whether 3 is the power to which n, to which the base 3 must be raised to obtain 27. Okay, let's take the question from here, that 3 raised to the power of n should be equal to 27. Okay, 3 raised to a certain number, say n should be equal to 27. All right, but we have here that our n is equal to 3. Okay, so we put that 3, check. Okay, so we put here that our n is raised to the power of 3. Okay, and this is 27, that our n is equal to 3. Okay, so we put here 27. All right, so that 3 times 3 times 3. Okay, and here so that 3 times 3 times 3 is equal to 27. All right, so what we have on the left hand side is equal to what we have on the right hand side. Okay, so we take the last question is the E question. Okay, it says that log 10,000 to base 10 is equal to n. Okay, log 10,000 to base 10 is equal to n. Okay, so this question simply means that what number would 10 be raised to for us to obtain 10,000. All right, so if we write this in index form, okay, this logarithm in the index form or exponential form, we'll have this, have this, have this. Okay, all right, so writing this down, writing 10,000 down in its index form, we'll have 110, sorry, we have 10 raised to the power of 3. Okay, notice that the bases on the both sides of the equation are equal, so they cancel off. So we have n is equal to 3. Okay, so 3 is the power which 10 must be raised to obtain 10 to have 10,000. Okay,